Okay, so I assigned you guys a little 4-1 to 4-5 review. We have a test coming up, but I just want to make sure you're very confident, feel really prepared for that. So I'm just going to try to go through some of that stuff. We have a little bit that I have not taught you that will be addressed on that test, but I just want to make sure everybody's feeling great, moving on to the next, or at least maybe a little bit less apprehensive. I know things are tough with going back and forth with distance learning and everything like that. So again, very sorry that we've had to deal with that, but we're going to do the best that we can. So anyway, let me go ahead and share you with a screen of that review, and let's kind of see how this plays out. So the review starts with a little bit of a view of the unit circle stuff. So remember, we have our box thing that we have done quite a number of times. So I have one of them right here. So rather than go back again through producing that, remember, we started with 0 and we counted to 4, and then 4 and counted to 1. We put square roots on all the numerators and we divided. I mean, we've done that quite a few times. So if I'm looking for the cosine of 5 pi over 6, it'd be right here at root 3 over 2. So I know root 3 over 2 is the magnitude of the answer, and since I'm counting by pi over 6s, this would be rotating down into the third quadrant where the cosine is negative because, again, a student trig class or all students take calculus, we're in the wrong quadrant. Now, 11 pi over 4, the tangent of any kind of pi over 4 is 1. So again, rotating by 4 is 4, 8, not quite 12. So again, we're in the second quadrant. Second quadrant does not have a positive tangent. Now, when you get to the cosecant of pi over 2, its reference is going to be pi over 2. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's sitting right here. Now, remember, one thing you could do is you just know that the reference is pi over 2. So we could look at the sine of pi over 2 as being 1. But that kind of makes sense because the sine is the y value and it's pointing at the number 1. And since we have to choose between positive and negative, positive wins because it's going up. Now, a secant is a reciprocal of a cosine. So if the cosine of pi over 4 is this, then the reciprocal of that, if you do the math, is just root 2. Remember, if you do your thing where you multiply by root 2 over root 2, it works. And this one just kind of just so happens a lot of things in here are landing in that second quadrant. And we know that the secant and the cosine are negative there. So 7 pi over 2 for a tangent ironically lands in the same place as that other one, I believe. That's 1, 2, 3, 4, 5, 6, 7. Actually, it's straight down. But notice its reference is pi over 2. It's pi over 2 from the axis. But the tangent of any kind of pi over 2 is undefined. See, the tangent of pi over 2 doesn't work. Almost done with all these hard ones, and then things are going to get faster. The sine of any kind of pi over 6 should be a half. Now, the only thing that could go wrong is if this was not reduced, but 19 is prime, so I know it has been. 19 pi over 6, there'd be 6, that would be 12, 18, 19 was just a little bit past that, 6, 12, 18, a little bit more reference of pi over 6. Sine is negative in that quadrant. And finally, if the tangent of pi over 2 is undefined, then the cotangent of pi over 2 is going to be 0. The reciprocal of undefined is 0. Now, when it comes to these unit conversions, I'm a little bit lazy on some of these. I like to do them without a calculator if I can, but sometimes they're just a little hard. Like this one's easy because those are both divisible by 10. But I notice those are not quite so nice. And so sometimes I can just recognize what they are, and sometimes I can't. So what I personally do is I just say, well, fine, I'm going to take 405 over 180. Notice that I'm not going to put the pi in that because pi is irrational. And I'm going to hit math, enter, enter. And it says, oh, that's 9/4. And then we'll put the pi back in. So that'd be 9 pi over 4. Same thing over here. Let's take 345 over 180. Math, double enter. Now you could do this by hand. You could say, well, what goes into both? And we could reduce that. It really does work. But I don't know. I just wanted to save some time. Now, of course, going the other way, instead of multiplying by pi over 180, we're going to multiply by 180 over pi. So the pi's cancel. And the thing that's weird is a lot of times, we do these kind of problems, but people get a little bit freaked out. They think it has to always, it's only radians because that's pi. No, it's radians because it doesn't have a degree sign. So just like that previous problem, we could either reduce by hand, or we could just take 13 times 180, because that's what I have, divided by 10, and I'm looking at 234 degrees. Notice I do have degrees because this was 180 over pi. And then this one would be negative 5 times 180 over 6. But you know what? I know that every pi over 6 is 30 degrees, so this should be 5 of those, so it should be negative 150 degrees, but let's just see if that's what I got, and you'll notice it is. So I didn't really need a calculator for 3b. Okay, so moving on to number 4, coterminal angles mean two angles that intersect in exactly the same place, rotating further or backwards or something like that. So if this says, let's take 405 and let's represent it by an angle that's negative, I'm just going to take 405 and take away 360 because that would be the same thing, but it's not negative yet. So let's take away 360 again. There it is. 315 degrees is the same angle, but just rotating the other direction. It's coterminal. It has exactly the same representation. But now it says, let's go ahead and let's try to rotate forward, because notice that 0 to 2 pi would be positive. So I'm going to add 8 pi over 4 until I get a positive answer. I'm going to add a full circle, just like here I added or subtracted 360. So let's see. If I added 8 pi over 4, I'd be at negative 1. And if I added 8 pi over 4 again, I'd get 7. And you'll notice that this is now a positive answer that has the same representation. And now this just says, give me one that's negative. So I'm going to go backwards 2 pi by counting by 12s. So if I went backwards, that'd be negative 17. Again, remember, rotating 2 pi or 360 degrees is just doing a full circle. You're still going to land in the same place. Now this says, hey, let's go above 2 pi. So let's be careful here. So I'm going to count by pi over 3s. So if I went up by 6 pi over 3, I landed at pi over 3. But that's not the right answer because that's not above 2 pi. That's just above 0. So let's not answer that. Let's go up one more time. And now this is bigger than 2 pi by just a little bit. So this is a coterminal angle. Now, moving on, trying to be kind of quick about this. I just wanted to get the first page done in this video. Reference angles asks you how much did you miss the x-axis by. Now, again, that's just kind of how we play the game. So if we're counting by tens, this would be 10 pi over 10. And this would be 20 pi over 10. So what we want to do is we want to decide how much do we miss the x-axis by at minimum, like the smallest value. So notice this one was off by exactly 3, but this one was off by 7. So we're going to pick the smaller one. So right here would be where we'd want to be, somewhere in this place. So 3 pi over 10 is my reference angle. In a similar way, I'll go to this one. This would be 360. I'm off by 115 degrees. That's a long way. If I got over to here to 540 degrees, now I'm actually only off by, I think it's 65. And remember, we're looking for a minimum. And it really doesn't matter if you rotate too far or not far enough. It's an absolute value. It's just how much did you miss by, okay? And now the beautiful thing is anytime it's one of those unit circle numbers, as long as it's reduced, we don't even have to work. So I just wrote pi over 4 and I'm good. This one, again, rotating backwards, 180 would have been good, but I missed by 18 degrees. 5 pi over 2, that's another unit circle problem. So again, I could draw it if we wanted to. 1, 2, 3, 4, 5 pi over 2s is right here. It missed the x-axis by exactly pi over 2. And then last one of those, we're going to count by 14. So 14/14 is really far away, but 28 pi over 14 is just a little bit too far. We missed by 3 of those. Okay, just about done. Last problem for this video. -6, +3. Remember, we always draw the triangle sitting on that axis. I will slow down on this one a little bit because what I personally really like to do, if I ever see common values, because trig is ratios. And so since you can take ratios, we always reduce ratios. So if we took this ratio of 3 to 6, that would be a ratio of 1 to -2. So the cool thing, and notice that I'm writing this in red inside because I wanted you to see that, 1 to -2, whoops, was not here on the screen, that's going to make this √5, Pythagorean theorem. Notice that I cut this in half, right? Actually, I divided by 3. So that's going to make this hypotenuse 3 √5. If you play with it and you actually try it, that's what you're going to find out. So in fact, I think I'm going to go back to blue on this 3 √5 to demonstrate here. So all of the blue ones are the larger values and the red ones are the smaller values. But if you look at the ratios, 3 over 3 √5 is the same as 1 over 1 √5. So if you make it smaller whenever you can by some kind of a reduction, you get easier answers. So rather than using these blue values, I'm going to use the red ones to answer my sign because you get the same thing. So I might as well use the reduced ones. So I'm going to go easy on myself and pick the tangents first. That would be 3/1/2 or -2 over 1. Now I'll do the hard ones. So when I do a sine, which is opposite over hypotenuse, that's 1 over √5, that's √5 over 5, which makes the cosecant just right here, √5 over 1. So no, I don't need to write the 1, I'm fine. So now the cosine is -2 over √5, also known as -2 roots of 5 over 5. And then this one is -√5 over 2. And one thing we did discuss in class is it really doesn't matter if you put the negative on the top or the bottom. So usually we just choose to write it in front because a positive divided by a negative is a negative. So we just put it in front. Makes it a little easier. So that's page 1 of that nice little review. Hopefully that helps. I'll go ahead and do a separate video for the next one. All right, see you guys. Bye.